Hello everyone, this is Janer from Sweden. I hope you're all fine. So this is the fourth actually live stream of this series, ESP32 Smart Screen Design. So we will continue with the layout, the routing. I think we can start if everything's fine, like the sound and the video, if everything is okay. It's very cold in Sweden. It's like minus 10 degree. My actually cars, all the glasses were frozen. I had to remove the ice on the front glass. Everything is okay. I think you can all hear very well and then see it as well. So we can start actually. So yeah, let's get back to the thing. Yes. So actually we were left here in the last session, last live stream, but I had actually a couple of things more. And also I did the placement. You can see it's like I arranged it a bit. So I placed the resistors and so on around the ESP32. Maybe I can do like this. This is better. And the USB connection on the right side and the cubic connector here. SD card is here. And this is the battery connector. So if there's an external battery, maybe we can use this one. So I'm not sure about the placement of this one. It might change. And then there are sensors, air quality sensor. This one is the accelerometer, and then the reset and the boot button. So I might actually take them a bit down somewhere here, or somewhere maybe here as well, so I can utilize the space better. And then I have added actually one more thing. Let me show it to you. So I added actually this component. So this is a little bit interesting. Maybe you will like it as well. So let me show it to you. Let me go to. Let's see if we can find. Oh, yeah, it's available in the browser. Yes. This is a push button actually load switch. It's a standalone one. So what it does basically is that there is a push button input. So okay, this is the example circuit. So there is the push button input and it's connected to switch input. So when you press for certain amount of duration, and then it enables from way in to way out. So and then you can power your circuit. When you actually press like longer than like the off time duration, and then it's actually disables the output. But this is a hard actually turning off. So the circuit, so it cuts off all the power, so there is no connection anymore. So one nice thing actually more as well, so you can shut it down from the MCU. So when you just actually give like pulse 1, and then it will shut it down. Of course, you need a capacitor here, otherwise I mean, when you give just pulse 1, and then it will immediately try to actually shut it off, and then it will lose power. So this duration should be a bit like maintained here. That's why we need to put this C1. Also, it suggests something. Yeah. And so this is a very nice one. For example, one use case of this one is actually in your phones or in your laptops. When you press like, let's say 10 seconds, it will actually shut it off completely. So without waiting for the software. So this is actually same thing. But probably in those devices, it's a bit more complex. This is just a simple standalone circuit actually. integrated into one package. Yes, so this is pretty nice actually. That's why I wanted to add this to have like one button turn it on and turn it off functionality. And then I decided to have actually I2C and the ESP UART pins on the output for the connector, for the breakout connector. So that's why I was going to change the connector. So I wanted to show you together like that how I'm doing it, so you can also learn to like replicate or maybe duplicate a component. So this is the new number. I found it on DigiK. So this time I'm gonna use the 16 number of positions. I was using actually I think 12 or 10. I don't remember, but anyways, I have downloaded the step file, but I haven't created the footprint yet. So let's do it together. I already have the small one, so this one. So I will actually use all of these paths. I will just actually make it on top of it. So what simply I'm selecting all of it from the center. Yes, and then just copy and place it here. And then I will delete the old model and then I will import the new model. And then it was this one, yes. And then let's see how it should be placed. So let's correct it. Yes. Now about the placement, so I do a simple trick. Altium is really good for this one. So you can basically add vertices. If you go to 3D body placement, you will see like add a snap point from vertices. So select the model first, and then it will automatically actually show you like where to add these snap points. I will add here actually to the center of this one, and then just one here, exactly to the middle, just middle of like center of the path. Try to align it here. So it will automatically select for you like if it is edges or if it is the center and so on. So I will go back to the yes. So then now I can actually grab it from this point and then I can just place it here. Yep. So it doesn't snap. What I need to do is just enable the snapping, shift E. Yeah, and then it's enabled. So this point, so there should be the pad actually. So pad should be aligned here. What I will do is I will just do like this, and then yep, perfectly aligned. And then I will just take this back, and then I will recreate the pads again. So the size of the pads are like 0.8 millimeter to 1 millimeter, and then I go to pad, just top, and then top layer. Design vector should be 13 because it should continue, and then I need to turn the snapping off, otherwise it will show some strange things. Yep, and then I will just place like this, and then bingo. Just fix these small details and then it will be ready actually. And top overlay, you can do Shift S as well, and then snapping on. Yeah, if the snapping is off, so you cannot actually, you see I cannot grab the point actually. If snapping is on, I can just go to the point easily. And then I should do this for the courtyard as well. So yeah, but it's not aligned yet, so I need to just select all of them and then move a bit. Yep, so it should be now center here. and then just realign this one. Yes, let me check the other. Yep, everything is fine so far. I think we can continue. Yes, Control S, and then I will just need to place at 16 connector, so it should be 6x2. So this one, yes, yep. Just let me change the name, and it was this one, right? So I don't forget later. And then let me replace the footprint. Don't forget to replace the footprint because I have created them separately, right? So I have the symbol, schematic symbol, but I don't have the footprint connected to this one yet. So what I just need to do is just press this pencil button and then library path, because I don't have the library actually within this project. So I can only find that one from the library path. So what I will do is I will need to go to my documents. Where is, oops, what happened? What happened? Ah, yeah. I will need to go to GitHub because I have it in the database. And then the connectors should be, and then it will ask for the name. Yes, and then it found it already. Yeah, we have replaced it. Now I just need to annotate it quickly. It's P2. There are some problems. I'm gonna fix that later. Oh, we made a mistake again. It should be more. No one warned me. So 16 is not this one. Yes, it should be 8 by, not 6 by. Sorry. Yes, it should be this one. No, that's 9 as well. What's happening? Yes, it should be this one now. But I can again fix it. Where is properties? Yes. And then again I go back, just again library path, select the connectors, put the name, and then it will find automatically. Yes, I can connect some more things. Yep, later if I have, but I will need to change the connector again. So at the moment it's like this. Also for these ones, let's align to the at the right. Yes, it looks better. It says there's a problem here. I know why, because I don't have this actually. Just copy and smart paste them. It's very fast. Connect them again. Let's see where they will need to go. Yeah, I think it should be here. Yes. Now they are connected, and then I need to reflect the changes to the, yep. There are problems, I know. I leave it to the end, especially the IC I showed you is not shown here because it was in my other computer actually that I designed. Yes. So if you remember in the older actually in the previous videos, I have put this middle point so that then I can snap any component here, but this was not actually correctly annotated because I changed it. Now I remember it was P2. I need to do it again. Let's quickly just ignore other problems. But yeah, so this is the middle point, and then I'm just taking down as much as I can because it should actually stick out a bit. It should protrude. yeah, for the bottom board. So yeah, because there will be an opening here. It looks okay at the moment, right? So let's continue. How is it going, guys, by the way? Do you like it? Do you like this type of videos? There is one more concern here actually. So I'm thinking to put a tape actually underneath the PCB. I'm not sure that's a feasible solution for a long-term product actually. So it might not be so good. Maybe I need to do something else. Maybe I can actually use the tape, and then I can actually stick this LCD to the plastic port. Also, I can maybe screw this PCB to that plastic as well. But I'm not sure yet. I need to talk to the mechanical guy to get together. I can easily find some spaces for screwing actually. No, that's not a problem later. But I need to get going now. Yes, let's start. So Shift S, and then I need to select transparent, and then yes, transparent is very good. So it makes some drawings transparent, and then you can see the trucks easily. So yeah, let's get started. I can start from these points, which is easy, but let me check if I have my rules actually correctly set. Clearance, yes, it is set. Width, it is set. Bias, it is set. And then yeah, polygon connect, it looks okay. Oh, there's a nice function here, auto. Yeah. Yep. So yes, I will start from this point, one by one. The width is 0.25 is okay, and this is going outside. So let's skip this one. This one also. So not all of them actually goes there. Yes. And then yes, let's continue from here. This stream was normally actually supposed to be at like 2 hours later at 17, but I forgot that there is a football match actually. Fenerbahçe and Galatasaray. Of course, I support Fenerbahçe, so that's why I had to change the time of the stream. So, is there anyone like supporting Galatasaray here, guys? And this is the, you see, I have actually specifically put this USB connector. Normally it was on the bottom, so I put it here so I can route it very easily. Me. What do you think the score will be, guys? Who will win? I think Fenerbahçe is like really powerful now, especially this season. But I forgot one thing, so that I didn't put. There is no connection here. I know why. Because I wanted to change actually these connections. If you see, so these connections are coming from here, and I want to change them to here actually, so I can easily route them from this point to here. so I don't need to go to underneath. This is actually very much possible when you work with the FPGAs. You know, FPGAs actually have IOs. They are multiplexed, so you can route any IO to anywhere in the bank usually. So when you're working with the FPGAs, you should always like look for the best routing option and then easily change the input and outputs. So always you need to talk to the FPGA designer or the VHDL coder, whoever does this. Or if you are doing it, you know it's what it is. Of course, Fenerbahçe 3-1. Let's see. Let's see supporters of Fenerbahçe and Galatasaray. So actually we can directly change it now. So let's see. I need to take the IOs here, so you know what I mean. So these one. But one bad thing is that I need to change the naming of these ones. I want to leave one because there's a shutdown option. I can use it. Yeah, I can so shut it down from the ESP32. So this shutdown option, I want to use it from this shutdown. So I want to use the MCU. Also for the button input, so the one I select is the turn on time is 1 second, turn off time is 3 seconds. So when you keep pressing for 3 seconds, it will shut it off. When you keep it pressing like for 1 second, it will turn it on. And also if you just press actually less than 1 second or for 1 second, so it will just give you like 1 for the button. So there is one diode, right? So it enables, so this is a pull-up, and then this just pulls down. So this diode enables actually one-way current. So this is V out for this one. So the pull-up is for this V out, and then this V pull-up is for this V in. When there is no V out, you need to have this pull-up, right? That's why they put this actually diode here. So they separate it. But when you press actually, so you make it grounded, and then there's a current flowing through from here, and then this voltage level will be 0, because the current will flow like this, and then it will be 0. Well, it won't be 0 because there is some actually voltage dropping over this, but it's way below the IO threshold level should be. So you shouldn't use like higher VF diode, forward voltage diode. You should use lower one. But you should make it. You should make sure actually to use a lower one and check the threshold of the MCU. Yes. So let's get going. So I need to just do this 0. And then do this. Yes. I just press shift and then drag it, so it just creates actually a sequential number like this. So we need to use only 7 of them. I just select all of them, Control Shift. Yeah, there are 7 of it, but I delete them. I'm gonna put okay, 6 of them because I will need to use one more. And then just Control C, Control Shift V, just paste as a port. Yep, and then just connect them. I will need to do this change on the other end as well. And then just let me copy it, interface, and then just delete this. It's a lot of iterative work actually, you know, it's not like just one single thing and you just design and it finishes. Unfortunately, no, it's not like that. So it's a lot of iterative things. And one pin will be empty, but we can utilize it later, so I can use something else. And then if they don't match well to the circuit, we will check it. Let's see who will. You see, it's now better, guys, to route it. I want to put actually some components here too. So I'm thinking to put actually the on-off switch here. It's not a switch; it's a push button. But I'm thinking to find something like this as well. I was checking it. Not like this, but not like this. Let me check you. What this, so this LCSC is sometimes really is good. They're really cheap, but it's like not easy to find a component that you are looking for because the naming, for example, mounting style is like lying. What's lying? It should be, if you go to DigiKey or Mauser, you will see like if it is vertical, if it is straight. Straight means it's like vertical or horizontal. So you should normally see this type of namings here. And the package, like plugin, what's plugin? It's a true hole actually. So sometimes the translations never work out, and then you need to find it yourself. Yeah. There are like true hole options. Actually, true hole might be better because the user actually presses so hard sometime. So you need to make sure that it's like strong enough on the board. And then you all know that all these USB Type-C connectors on the phones actually get broken easily because they push it so hard. So I'm thinking something like this, but it will bring some more actually assembly work because there should be some through hole soldering, which I don't like. I need to find a compromise actually. So there are both options used, I know, but I think it's not that cheap. And the length of this height or length, I don't know what's called, this cup length, let's so to say, this black thing, the key, is important. Why? Because it will actually determine where I can place it in my board. So and then I can have the plastic cup actually sitting on top of it. So that's why you need to check it with your mechanical engineer. So it's not just a simple thing that you can put it easily. So I need to select one carefully, and then I need to give a 3D model to my mechanical guy, and then he should check around if it is enough or if I need to find something else. And there are some options like this, of course. But the stock is 20, it's not enough. Yeah, stock is important when you are designing something, guys. So don't pick something which has 20 quantities in stock. It will create a problem later on. And then I see up. This is a very strange footprint, by the way. Like, anyway, there are like dozens of available, so thousands of available. Yeah. I need to pick this carefully, but let's continue. So I want to do something like keep pressing Alt and then just press and Shift. Sorry, Alt and Shift. Press them together at the same time, and then just select them. And then go there. In interactive multi-rate routing, I guess. All primitives must be on signal, same signal. It is. It is actually. Why? Normally I was able to do this. Let's just select 3. Cannot multi-route. All start primitives must be on the same signal layer. Oh. Altium was normally working for this one, and it's strange now it's not working. So we go one by one instead. Yep, and then I need to change the connections. As you see, it is not really optimized. So this should go to maybe 11. So 5 should go to pin 11. And then let's do like that. So 5 should go to pin 11. Yes, and then 4 should go to 12. Oops. 4 should go to 12. And then it should continue, yeah. 3 should go to 9. 3 should go to 9. 10 should be 2. Yes, 2, and then I think it should be like this. Oops. So I can lock this and then it will not move anymore. Yes. I think it should be better now. Let's see if we can go. No, it's too big. So I need to I need to select something thinner. Yes. Since these are like signals only, low power signals, it's not very important to design them like thick or thin. So it depends usually, but yeah. So let me make them equal. Yes. You see, and then so yes. Also, I forgot to put the differential for the USB pin, so I need to put that rule here. Differential pair. I should say diff 90. It is 90 ohm, right? Diff 90 and diff 90 here. Also diff 90 here. So I need to put the net name first because it will not recognize otherwise. USB P USB and Altium recognizes actually with the suffixes, those suffix. So you need to have it. Yep. So it matches actually these two as a differential pair and these two. So I need to update so I can have these rules transferred to right. Yeah, I have it now. So let's set the differential impedance and so on stack up. You need to go to layer stack manager. And then you need to go to impedance tab. So you need to create an impedance profile. So the differential and the target impedance is 90 ohms, and then stack symmetry. So it automatically calculates it for you actually. Let's calculate it right. So it's, uh, so this is really nice. You don't need to do anything. So we have this D90, and then we need to go to rules, and then there should be differential pairs routing here, yes, and then you should select ESP90, yes. So because we have added in the schematic, so that's a differential pair class, and then you will need to select the impedance profile you have created. So you select this one, and then D90, it was D90. So you apply it, and then yes, your rule is now created. That's suggested by the line termination register, actually suggested by ESP32 Espressif. So you should usually follow those ones. And yeah, sometimes yes, actually termination registers are, or the termination is good actually when you have fast signals. But this is not fast, right? So this is USB 1.1. It will work even though you don't do the let's say impedance matching and so on, because it's very slow signal. But it's a good practice to do it all the time. Yes, so let me do it a little bit like this, and then let's say in differential power pair routing. So oops, it's getting very strange. What's happening? Why is it becoming like this? But why? This is very strange. Is it like this? How was the rules? But the gap should be 0.27, 127. Oh my god, is there a bug in the... I don't understand why. The G is here like 0.127. Yeah, that's correct. I don't understand. Oh my god. But why? Is there a problem in the rules or something? Differentials power pair routing. Okay, I think I know it. I think I made a mistake. I didn't select. Yeah, this is the diff90. I didn't add the differential class. Yeah, USB 90, so it doesn't see it. Yeah, and then I need to add it again, and then it should be fixed now. Yes. This is not perfectly aligned. I will align it later. So let me do like this. Yes. Yeah, this is really bad for the USB Type-C connector. You need to always do this. So it should be like this, which I hate actually. Yeah, I can have something like this. I think it looks a bit better, but not still best. Yeah, I will check it later more. So yes, designing a PCB takes so much time, unfortunately. Let me connect these ones. I think I think AI can help us for this routing. There is one company actually, they have this routing options of things. So now I need to have these connections here. Yeah, then I need to distribute the power. So I try to do it as thick as possible to race. But I think 0.5 is okay. So if we select and then there's a tool, Saturn PCB, you can see how much current you can carry actually over this trace. Yeah, I think they use Mentor Expedition in ABB in my company, but we will switch to Altium. I don't think it's that powerful. I have never used it, by the way, but that looks a very difficult tool to use. Expedition. Conductor properties, let's see, 0.5. 0.5. It says it can carry 2 amps actually current. You can download this Saturn PCB tool. It's a really nice thing. It's free. It's updated actually over time. So yes, and then I just need to connect this one as well, but maybe a smaller trace. I will fix that one as well. Yep. So the USB should go to there. Maybe I can route this one. Yeah, I can run this one in the third layer. The second layer should be the ground. Guys, I will do it. I will do a polygon. Yep. So shift space. I think, yeah, many companies are switching to Altium nowadays. But by the way, Altium is more expensive actually. Yeah, there's a key path layer. But I don't like this thin edge as well, but I will check it anyway. And then let change to ground. Yes. Pour over all same net objects. Repower. Yes. I will need to cut this. Then I can put pour cutout. I want to do actually a bit bigger than this, so I can maintain the antenna signal quality. Yes, if I do report, yes, it will be good. Yeah, unfortunately, Altium is very expensive. They have additional services as well, like PLM and so on. I have never used it actually, but in big companies that would be essential, right? Because it helps a lot. Yeah, we poured our ground. So let's do the design for the USB VCC. So USB VCC supposed to be going like from here, there, and then there. So what we can do is we can do this polygon push. Why it's getting slow when I select polygon mode? Altium is I'm using the latest version, 24 version. Something is wrong. It has never been this slow. I don't know. Altium is actually very well known with their bugs as well. But recently they have focused actually solving those bugs. Anyway, so it should be something like this. Maybe we can change later if we need something else. It should be USB VCC. USB VBus, yes. So yeah. And then I can also have some solid region here because I want to fill it with bias. So I can go to place via, and yeah, this is nice. I will place actually more than one. Ah, this is USB VCC. That's supposed to be USB VCC, not USB B bus. USB VCC. And then this should be the net should change to VCC. But why is it? Yeah, there is the ground underneath. That's why it gives a. We should shelve it. Yeah. So it should be something like this, and then just copy and paste. Let's see how much actually current this via can carry. So it's 0.3 millimeter hole size and 0.6 diameter. And we should go to via properties, via hole diameter 0.3, pad diameter should be 0.6. I think the height should be 1.6. It can carry 2 ohms. It's really nice, but there is the impedance via inductance, and the impedance, yeah, it's 50 ohms almost. So that's why we need to put as much as possible, as many as possible in parallel. So we can reduce the inductance and the impedance as well. So we don't like these one single connections. And then is it properly connected? Yes, it looks it's properly connected. So we can now distribute it to these points USB VCC. And then I can have this as thick as possible because I think this is the power connection. So let me select this 0.5 mm. So 3 here as well. Yeah, it looks like I can combine many of them to actually see 1 point. Yeah, you see it's like 0 volt, 0 volt, 0 volt, 0 volt. This is ground, and this is, yeah, connection. For the analog circuit, you should try to, the power circuit, you should try to uh, route the traces with the thickest maximum or the possible option. This is battery enable, it's just a signal, you don't have to route it very like thick. Maybe I can do like this. I don't know. And then this is it's probably the battery. Yes, the battery should be connected here. So yeah, I can maybe do like this. Can put a fill. So ah, yes, I think it's battery, and then also I should have it here. I see. Yep, I can cover these battery pins. Yep, you see it's looking nice now. Yep, now this point. So we need something like this. So yeah, you shouldn't actually design them or put them so close to the connector because you should leave some space. And then it is good for the thermal conductivity, also for the assembly process, and also when later when you want to change this connector. This is not actually hand solderable easily. Yeah, you can do soldering, but you need to maybe expand this or yeah, you can like make them wider a bit, so you can easily solder with the soldering gun. Like I was soldering actually yesterday 5 boards. It was a bit difficult. Relaxation, like I think watching is really nice. Someone is designing and you watch it. Later on, when I actually open the videos, it's like really nice, like a magic. But this needs some maybe correction later. So I didn't like how it goes. See, it doesn't seem really nice. Okay. And the USB, the SD card connector. So we should maybe design the 0.2. For the signals, you shouldn't actually go so thick. It's not that important. So you can have like 0.15, 0.2. Of course, depends on the manufacturability. I didn't like this. But I know one thing, that you can change these pins. So it's multiplexed, if I'm not wrong. Uh, so let's swap the TX actually with, so it should be uh, chip select TX, clock, and RX. So chip select should go to TX. Chip select should go to TX, and then this should change as well. Chip select should go to TX, and then what will happen? Second signal should be the TX, and then TX should be the clock. Yep. Wait, by the way. Yep, TX should go to clock, the second one. And then the third one, it should be clock. Yes. And then the third one should be clock. Yes. Let me align them again. Right, I think this was on the TX and this one was on the clock, if I'm not wrong. Yes, it should be perfectly aligned now, arranged now. You see. I need to do this. That's it now. Yep. And then I will need to fix this connections as well, but they will mostly come from here. And then these other parts too. And then probably I will be done actually, so it requires a bit much maybe to work too. Yep. I think it's enough today. What do you think, guys? Maybe I should convert it like this because I want to place the connector inside actually. So this should remain inside and this should go out. But this is a bit dangerous actually. When you connect the battery here, you expose the pins outside. So I need to think of a solution, or I shouldn't put this one at all when I place this one. But now it looks clean and like manufacturable. So this is nice. And then let's see. So I will finish the rest layout on my own, and then I will show you the results, also the important points that you need to check. But I think you can actually design it on your own something as well. But I think today is enough. Yep, I will finish it soon. If you don't have any questions, I can answer them before I end the stream. Otherwise, I hope you actually after the new. I hope I see you after the new year actually, because this will be this will be the latest stream probably. So I wish you happy new year to everyone, and then yeah, see you after new year.